solving the question Koko eating bananas. So Koko loves to eat bananas and there are n piles of bananas. Okay. So the first pile has 3 bananas, second has 6 bananas, third has 7 bananas and fourth has 11 bananas. And the guards have gone and will come back in 8 hours, which means the guards have gone for 8 hours. So Koko has 8 hours to finish the piles of bananas. Right. Now Koko can decide banana per hour eating speed. So we will be like, our answer space is the eating speed of speed of Koko, like how many bananas can Koko eat in 1 hour, right? So it next then says that each hour she chooses some piles of bananas and eat k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more banana during this hour. I think it is a very important line in this question, like she eats all of them instead and will not eat any more banana during this hour. What it is trying to say, like, let k is equals to speed of Koko eating the banana, like k is equals to 4. Koko eats 4 bananas per hour. Now we go to this, like the first index, 0th, and there are 3 bananas in this pile. Koko has a speed of 4. Now it will if the pile has less than k bananas, she will eat all of them instead. So Koko will eat only 3 bananas in the first hour, and then she will move on to the second pile, and in the second pile there are 6 bananas. Koko has a speed of 4, so Koko will eat 4 bananas in the second hour. Now Koko is left with 2 bananas from this second pile, so Koko will eat the rest of the 2 bananas in the third hour. Now Koko will move on to 7th, like the third pile with 7 bananas. So here, and Koko will eat 4 in the fourth hour. Similarly, Koko is left with 3 bananas, so Koko will only eat 3 bananas now in the fifth hour. So you can see here, like Koko cannot, like if in the second hour Koko ate 4 bananas and 2 bananas are left from the same pile, in the third hour she will eat the leftover, right? She can only eat 2 bananas in the third hour. If time is left, like she cannot jump over to the second this pile. Now in 7th, in this third pile, if there are 7 bananas and Koko can only eat 4, the rest over she will eat in the next hour, and if time is left she cannot jump over to this last pile, right? If this is the next pile, she can still eat only 4 and it will be eaten in the 6th hour itself. She cannot, like if time is left, she cannot come and eat in the 7th pile, and if still time is left, she cannot come and jump to the other pile. Okay, I hope I am able to explain this. So now the minimum amount of bananas that Koko can eat is 1, because here Koko likes to eat slowly but still wants to finish eating all of the bananas before the guard returns. Okay, so we'll find she can eat minimum of 1 banana and maximum of 11. Now why are we saying, we are considering this example here, like for this specific example, the minimum can be 1 and maximum can be 11. Why we chose 11 is, if Koko decides to eat 11 bananas in 1 hour, she will still finish it in 4 hours, right? Because we cannot jump the piles. If she eats 11, here she will only eat 3, here she will only eat 6, here she will only eat 7, and here she will only eat 11. Now if we try to move beyond 11, like 12, if we make max 12, still it will only take 4 hours, right? Because the maximum is 11. Still in 1 hour she only be able to eat 11. She cannot jump and move, right? So it will be the maximum of whatever the pile we have. Now what we wish to calculate is, of course we will find speed using binary search, but also we need hour that hour that will be required at a specific speed, like, let me explain this. So still we will have k is equals to 4 as our example's speed. Now if you have 3 piles, so the r will be 3 by 4, whatever comes, plus, like this is the time, right? This time is equals to 3 bananas and 4 is the speed we have, right? So this is the time. So 3 by 4 plus 6 by 4 plus 7 by 4 plus 11 by 4, right? This is the total time we will get if we are eating with a speed of 4, and then we will compare this time with h. Compare time with h. Okay, so if time is like we completed eating in 5, which is less than 8, hence the speed, like time taken is less, meaning speed is more. Here we should know that time is inversely proportional to speed. Okay, so speed is more, which means we need to reduce the speed. We need to reduce the speed, hence we will shift r, which is the right pointer, to m minus 1, so that we can narrow down our binary search between 2l and m minus 1. Like our main focus will shift towards, like, we know that we cannot have any speed which is more than 5, right? So we will search only between 1 and 4. I hope I'm able to explain this. Now if time is 10, which is greater than 8, so time taken is more, meaning speed is less, meaning we need to increase the speed, hence we will look for speeds more than whatever we had here, right? X speed is more, we need to reduce speed, hence we will we can also say, like, we need our speed to be less than x, be more than x, right? So we will shift left pointer to m plus 1. I hope I'm clear and I'm able to explain this properly. Okay, so we will now try to code this entire thing. So what we're saying is like left pointer to minimum and right pointer to the maximum value of files. Now while left is less than equal to right, we want speed. Like we usually find the midpoint because it is binary search, but I'm writing it as speed. We have it, okay, middle speed. Speed m is equals to left plus right minus left by 2. So you might ask, why are we writing it like this rather than just left plus right, left plus, oh god, left plus right by 2? Because in Java this is fine, this will work, but no, in Python, I'm sorry, like in Python this will work very finely, but in Java and C++ this may cause integer overflow. Hence, to prevent integer overflow, we use this. So now we will calculate R, which will be used as a feasibility check. Like, are we able to complete the are we able to eat all of the piles in this time? Okay, so it will be like we have to define another function. So we'll write like total R of self piles and speed. Now we'll write as R is equals to 0 for I in piles, R is equals to I by speed. I hope you get this from here, this thing. Okay, and now we will use math dot ceil. Okay, I'll explain you in a second why we use ceil. So in math dot ceil we use it because like we have 7 divided by 4. Okay, 7 by 4, this will give us 1.75, which rounds up to 2 hours, right? Now if some time is left, Koko cannot jump to another pile, no, she will only be allowed to eat whatever is left from here. So we just use math.ceil for this thing, and we'll return hour. Now it's total h, and we will give it piles and speed, but here we will write it as self dot. We are writing and we are using self because if we don't use self, Python won't be able to find this function inside the class to tell that this function is present in this class itself. We use self. Okay, so if hour is less than or equal to h, as we explained here, we will do this equals to m minus 1, else we will do is left is equals to m plus 1, right? And now we will return L. Why are we specifically returning L? Is because when we move out of this loop, when this loop gets finish and we get out of this, we can see that L is equals to R, and in some cases R can cross L. Hence R would be an invalid minimum answer. So to be safe, L is the only minimum possible valid solution, we can say, right? Now let's talk about the time complexity. So time complexity in this question would be, since we applied binary search, so as we know the time complexity so in time complexity in binary search we know that we have an array of n size n, then in next iteration it will be n by 2, in n by 4, and if we do this so we can say that time complexity would be big of log base 2 of maximum of piles, because that what our search space is, like, minimum can be 1, then 2, 3, 4, 2, 10, 11. So time complexity for binary search would be this. If we were dividing this array into 3 parts, then this base would change to 3, and if we are dividing it into 4 parts, this would change to 4. So in binary search we only do it twice, so 2, and then we are also using hour, like we are trying to find hour to validate, no, not to validate, but we are using hour to check the feasibility, right? If the total sum of hours with that certain speed is comparable to h, is less than h or greater than h, hence we are traversing n times, right? We are visiting each pile and we are calculating the time for each pile individually, and this is happening inside of the binary search, right? We are doing it inside the binary search, hence we can write this as n into this thing. Now space complexity would be big of 1, since we are not using any extra data structure to store. Let's see if we can run this answer. Okay, so this will be speed, and then this would be speed and speed is not defined, so it's speed and so we can see like our test cases got accepted. Okay, yeah, let's try and submit this. So it was successful. I hope you understood the solution. If you have any doubt or anything you want me to improve, do comment down below.